So hi guys, so in this lecture we'll be continuing on comparing compounds based on their acidic strengths. I hope you are enjoying it. Okay, so let's compare acidic strength of the following compounds. And this one. So which carbon atom would you like to remove hydrogen from? Obviously these carbon atoms, this one, and in this case this one, and in this case this one. So which would be having the highest acidic strength? So in this case hyperconjugation would be possible in both direction, in this one and this one. In this case only in one direction, and in this case ester formation is there, so very less, and in this case at least one direction it is available. So actually how do we compare between this this and this? Even if now the point to note is, even if this is not involved in resonance, this is still there is still a minus I effect attached here as a ester group. So still I can say that A is greater than D is greater than B is greater than C. Okay, let's look at the second example. We have this hydrogen and this hydrogen. So what would be the strength? When it leaves, it would be negative charge here. When it leaves, it would be negative charge here. But this is getting aromatic from, and this is getting anti-aromatic. So acidic strength is of this order. Third example is okay. So what is the acidic strength here? In this case, we have a minus in all the cases. So in this case there is a minus M group attached. In this case there is a plus I group attached. In this case there is a minus M, just to show that it is more minus M. And this case, I draw the same structure again. Let me make it OCH3. So in this case it would be a plus M effect. So and this case would be plus I effect. Okay, so acidic strength would be A, then C, then D, then B. I hope you are getting why I am placing this order. So let us compare acidic strength in this of different hydrogen atom within the same compound. Let us say we want to compare acidic strength of H1, H2 and H3. Okay, so let us see in detail what conjugated base are formed by when we remove H1, when we remove H2, and when we remove H3. Okay, so in this case there is resonance taking place. In this case extended resonance is taking place. In this case, no resonance is taking place, only the compounds resonance, internal resonance is taking place, and in this case at least some resonance is taking place. So the order would be S3 is more acidic, then H1, then H2. Okay, so let us look into some facts now. We are done with the examples, so let's comparison of acids based on facts, right? So let me write down. So this is considered as superacid, father of all acids. Then we have our SO3H. Then we have hydronium ion. This is also a superacid. Then we have RCO2H. Then we have phenol. Then we have simple alcohol. So with phenol we can say that phenol shares its position with it can be RNH2 or HCN or this one. So all these compounds share acidic strengths with phenol. Okay, so after CH3OH we have H2O, then this, then this, then this alkyne, then I'm writing over here we have NH3, then H2, then alkene, and finally alkane. So this is the order of acids, acidic strengths. So we can compare only if active hydrogen is attached with some comparative electronegative element, right? So we cannot actually compare these two acids, CH3 and CH3OH. These are not comparative. For being comparative, we can only compare active hydrogen if it's attached to the same electronegative element. In this case, it is attached to hydrogen. In this case, it is attached to carbon. Okay. And one more thing, that as the bond angle increases means by bond angle increasing I means more S character. You know that we have sp hybridization, sp2 hybridization, and sp3 hybridization. In this case, bond angle is 180 degree, 120 degree, and 109 degree. So as the number of S character increases, the bond angle also S character increases, bond angle also increases, and as the bond angle increases, acidic strength also increases, right? Why acidic strength increases? Because it becomes more electronegative. Hence electronegative element or atom wants itself to be negatively charged, right? So with this we complete this lecture, and from the next lecture we'll be seeing more of the properties on acidic strengths. Okay.